Section 10.5. This is the last section in the class. It'll be a couple of videos at least, so let's get started. 10.5 is graphing quadratic functions. So our quadratic functions have the form ax squared plus bx plus c. When we graph it, it's called a parabola. The features of a parabola, there are many, and they're all very important. And the first is that the parabola opens up. So we have a parabola is a U-shaped graph, opens up if the a, meaning the number in front of the x squared, is positive, and down, so a downward facing U-shape, if the a is negative. So the a is that number in front of the x squared. The lowest or highest point is called the vertex. The x coordinate is found with this little formula, x equals negative b over 2a. So if you are working on a test, you want to make sure you have this formula handy. If you are going in to take the final exam and you have a note card, this is one of those formulas you would want to include on your note card. To find the y coordinate, you just substitute whatever number you find back up into your function for the x, and that'll give you your y coordinate. The axis of symmetry is an imaginary vertical line over which the graph reflects. So our graph is the same on the left and the right, and we have this imaginary line of symmetry. The formula for that is the same as the x-coordinate of the vertex. The y-intercept is found by doing f of 0, subbing 0 in for x, which is always going to be the ordered pair 0, c. C is the number on the end. The domain is always negative to positive infinity. The range is one of these two options. If it opens down, the range is negative infinity to the vertex with a bracket on the vertex and a parenthesis on the infinity. If it opens up, it's a bracket, the vertex value to infinity with a parenthesis. The x-intercepts are f of x equals 0. So this is going to take probably more work than any of the other steps because you're going to have to solve with factoring or the quadratic formula, or if you liked completing the square, you could use completing the square. The discriminant, which is what we talked about in section 10.2, is going to tell us what to expect as far as x-intercepts. Will we have 1? Will we have 2? Will we have 0? So that's how that discriminant value is helpful. In our first example, it says graph, state the domain and range. So I'm going to go through all of those 6 features. The first feature is telling if the parabola opens upward or downward. Since there is a negative in front of the x squared term, my parabola is going to open down. The second step is about finding the vertex. To find the vertex, we use the formula x equals negative b over 2 times a. Simplifying this, I get positive 8 over negative 4, which is negative 2. And that's half of what I need. My vertex is an ordered pair, so I need the y that goes with it. To do that, I substitute negative 2 in place of the x and solve this out. And when I do that, I get negative 8 plus 16 is 8, plus 1 is 9. So my vertex is at the ordered pair, negative 2, 9. Step 3, the axis of symmetry, I'm going to abbreviate AOS for axis of symmetry, is just the x portion of the vertex, x equals negative 2. Step 4, the y-intercept is going to be the ordered pair 0, 1, because it's always that number that does not have the x on it. Step 5, the domain is negative to positive infinity, and the range, since my parabola opens down, the range is negative infinity to the y-coordinate of the vertex. And step 6, finding the x-intercepts. I set my function equal to 0, and then I would try factoring first because factoring is faster if it works. This one does not factor, so I use the quadratic formula. And I'm going to just do some of my work in my head. 8 squared is 64. 4 times negative 2 times positive 1. It's 4ac, ends up being positive 8, all over 2 times a. So 8 plus or minus the square root of 72 over 4. 72 is 36 and 2. So we have 8 over 4 plus or minus 6 square root of 2 over 4, which is, oops, 4 is negative, almost lost that. We have negative 2 plus or minus. So even though there's a negative here, because I have both signs anyway, I have both signs still, I can ignore that. So I have 3 square root of 2 over 2. So these are my zeros, or my x-intercepts. For graphing purposes, I would want to change those into decimal. So I'll do that here in just a moment. If I have to list my x-intercepts as ordered pairs, you would have to split them up. I'm running out of space here. By split them up, I mean split up the plus and the minus sign. So that whole expression is the x. All right, then I need to graph this. So I'm going to put all of my information on a graph. This is 10.5, example 1, part A. And what I have is a vertex at negative 2, 9. I need decimal values. Let's see, it looks like I don't have those written down, so we'll deal with that in just a minute. Let's go with negative 2, 9. There's my vertex. My axis of symmetry is just a dash. It's not really there. I put it in as a dashed line to remind me that this is a line of symmetry. My y-intercept is 0, 1. By symmetry, since I have this point 2 steps away on the right side of my axis of symmetry, I also have a point 2 steps on the left side. So I really don't even need to plot my x-intercepts because 3 points is enough. My x-intercepts are going to be somewhere here and here. Those would be decimal values. I'd have to use my calculator to compute. When you're in MyLabs, you're going to use the vertex tool when you're graphing, not the vertex tool, the parabola tool. You're going to use the parabola tool and then follow the instructions. If I remember right, it has you select the vertex, so you click there, and it has you select another point, so you click there, and it would automatically generate the parabola. All right, we will do more examples starting in the next video.